Hi students, welcome to preliminary chemistry and the energy topic, and this is video number 7 on organic nomenclature. We've kind of skated around this before, but I wanted to just make sure we've got one nice video which just hones in on the key things that you need to know about naming organic compounds, particularly hydrocarbons. So the first and important thing, I guess, is that there is a very large range of carbon compounds. We're not going to go anywhere near scratching the surface of these, but we will focus in at this point on the compounds that are the some of the more common hydrocarbons. And what we're going to do is we're going to follow the IUPAC system, which is an international system, Union of Pure and Applied Chemistry, if you want all the words in the acronym. That is a standard, a global standard for naming different compounds. So we get a consistency in the way we use these names. What we're going to be looking at is 3 homologous series, which are groups of compounds with similar properties and also a similar general formulae, and you'll see this as we go along. So the 3 homologous series we want to look at are the alkanes, the alkenes, and the alkynes. Now, alkanes have a single bond, so they are characterized by only single bonds between the carbons. They have the general form CnH2n plus 2. So the simplest of these is methane, which has 1 carbon, and so 2 times 1 is 2 plus 2 is 4. So methane, for example, is CH4, and that's how that formula works. Alkenes have a double bond, and what we've done is we've removed 2 of the hydrogens in order to form that bond. So obviously there can be no methane because you can't have a double bond between carbon and itself. So the first alkene is ethene, and these have the general formula CnH2n. Okay, so the first one is, as I said, ethene, so it would be C2 and H4. When we go to the alkynes, we have a triple bond. So there's a carbon with 3 bonds between the 2 carbons. The rest of the carbons, if there are more carbons in the chain, will only have single bonds between them. We won't get too complex at this point in time. And again, each bond is removing 2 hydrogens. So this time we have CnH2n minus 2. Again, you can't have a triple bond with only 1 carbon, so there is no methine, but there is an ethine, and that would have the formula C2H2. So let's work our way through a few of these now. The important thing to remember about nomenclature for hydrocarbons is the prefix gives you the number of carbons. So therefore, meth is 1, eth is 2, prop is 3, bute is 4, 4 letters for prop is 3, and 3 letters for bute is 4. I don't know why, but that's the way it is. It is back to front. If you can remember that, you'll be right. If you get that far, pent is 5, hex is 6, hept is 7, and we only have to go up to oct of 8. So this is the prefix, and it tells us the number of carbons. The suffix is the functional group. The functional group is what links a homologous series together. So all the alkanes, which are a homologous series, are linked by the fact that they have single bonds. That's their functional group. So an ane will have single bond. An ene will have a double bond. And an ine will have a triple bond. So what does this look like in practice? Well, in practice, if we had pent, ane, then the pent would tell us that there are 5, 2, 3, 4, 5 carbons. The ane tells us that there are only single bonds. We don't have to worry about that. I've just got single bonds. And once I have my single bonds in, then everything else is just filled with hydrogens. Because they're hydrocarbons, that's all there is. Things can get a little bit trickier when we have double or triple bonds. And the reason for that is that where there is ambiguity, we use one additional thing in the name, and that is a numerical value for the carbon. So here is an example of one such carbon chain. Okay, so first of all, I'll put one more in. Let's put it here. Okay. So I count up my numbers of carbons: 1, 2, 3, 4, 5, 6. So 6 is this one. So it's going to be hex something. Now I can see that here there is a double bond, and my double bond is this one. So that's ene. So it's hex-ene. Now when I start putting my hydrogens in, remember I need to make sure that the hydrogens are only going to be bonded to a carbon. But all of the carbons need to have 4 bonds around them. So here is 1, 2, 3, 4. So if you make sure that you have enough hydrogens to fill everything, we're all good. The only problem with this name is hexene doesn't tell me whether the double bond is in this position. The double bond could also be in this position here. I'll call this B, I'll call this A. A is where it is. So how do we know? Well, we know by numbering. So I'm not sure. Let's see if I can use a blue color here to do this. So I'm going to number 2 ways. 1, 2, 3, 4, 5, 6. So we go along the chain from 1 to 6. We could also start at the other end. There's no reason why we have to go left to right. We can go right to left. So how do we know which one we use? 1, 2, 3, 4, 5, 6. So here are 4 options. Okay, 4 options. We can use 2, 3, 4, or 5, depending on which way we're counting from. Well, the rule is smallest. So we use the smallest number if we need one. We didn't with pentane. We didn't need a number, but for this one we do. So this smallest number here is 2. So it's hex-2-ene. That's its correct name, is hex-2-ene. So that's telling you that the double bond, the ene, is on the second carbon. And when we count from the left, the second carbon is the one that has a double bond attached to it. If it was in position B, then we would actually have to call it hex-1-ene, because 1 would then be the smallest number. So a quick wrap up then. Alkanes contain only single carbon-carbon bonds. Alkanes are called saturated hydrocarbons because of this. Alkenes contain a double carbon-carbon bond at one end of the molecule and single carbon-carbon bonds elsewhere. Now most of what we're going to be looking at are end carbons, so they're going to be 1-ene. But in the example I gave you before, they're not all necessarily the case. So at least you've now seen some examples of where they're not. Alkenes are unsaturated hydrocarbons, and that double bond is very reactive, so we can add across that double bond. The single bonds, on the other hand, are more stable, and so the alkanes are generally less reactive than the alkenes. But we'll have a little bit more look at alkanes and alkenes in the next video. Thanks for watching.